Hello everyone. Today I want to walk you through a backend project I have built. It is an event-driven user activity tracking system. The main goal of this project was to build a system that can handle the tracking user actions like page views, button clicks, or logins without slowing down the main application. Without slowing down the main application, uh, we, we can handle tracking users actions like views, page views, button clicks, and logins, etc. Um, let's run this project. We have to. Uh, this project is fully containerizing using the Docker, and we have to run the containers. We have to create the containers. This and run this command and wait for some time. That's it. The UVCon server is running, and first we have to check that the services are working or not. Therefore, use this command docker compose ps. It will show that uh, what the services are running in the containers. It's like here showing that healthy user tracking service and user producer service is unhealthy. For that, we have to run the uh, build this. Okay, let's run this command. Okay, we can see that consumer service and all services are running in the containers. We can see that in the use yes user tracking service and user MySQL service and producer service and RabbitMQ services are all healthy. Now we will go to the Swagger. This is our Swagger UI for this project. Can reload it and check that health. See that we can status is healthy, and when go to the event tracking track event. Now we will check with the wrong details like this. We are giving wrong date is an string, but we have to put real date like hyphen numbers hyphen like that. But we will giving that date instead of date. We will give a string. Paste this, and we can see that errors fail required. Field required means input input should be valid date time and invalid character in ES. See, the validation is done, and next we will do with the correct data. See, event successfully accepted for a processing. Now we will go to the terminal and see See that user ID 123 is 3 stored in the database, processed and stored in database. This is done by the consumer service. Okay. Usually in a simple API, when a user does something like logging or page review, the server takes that request and immediately writes it into a database. But if you have thousands of users, imagine that you have thousands of users and clicking things at the same time. Those thousand users are clicking the services at the same time, clicking things at the same time. The database can become a bottleneck. Okay, and the user's app might freeze while it waits for the output. To fix that, I designed this using an event-driven architecture. Like this is event services, microservice architecture. It these services are independent to each other. They done they done works in independently. RabbitMQ service and MySQL service. This is for the database service, and this is for the producer service and consumer service. I split this system into completely separated microservices using the Docker Compose. First, we have producer API, which I built using the FastAPI. When a user action happens, this API receives producer API. This is the producer API. When a user action happens, this API receives a payload, but instead of taking to the database, it instantly drops that message into a RabbitMQ message broker and tells the user, got it. It request accepted. It is incredibly fast. Okay, whenever a user clicks on any event, it takes the on payload and go to this publish event, publish, then can see that publish event data and connection. RabbitMQ connection is not established if the RabbitMQ is not connected to the service, it will show that RabbitMQ connection is not uh, established. Message body, it encodes the message body and publish the message into the queue. Publish the message into the queue and close the connection with the RabbitMQ. Whenever a user sends a request or any event, it instantly gives it accepts the action and it will process it in the background. Then the request sitting on the other side of RabbitMQ is my consumer service written in Python and SQL Alchemy. This worker silently pulls those messages out of the queue one by one and safely writes them into a MySQL database in the background. Um, this consumer service, like okay, this consumer service takes the event one by one in the RabbitMQ and process it and safely return those operations in the database, MySQL database. It this function will be process the message and This method will be connect to the RabbitMQ, and then this method will be process the message and commit the session and commit the data in the database. Okay. One of the best parts about building this was solving in the real world distributed system problems that popped up. For example, when I first containerized everything, I am I ran into a classic race condition. Docker would start all the containers at once, but my FastAPI producer would boot up in milliseconds and try to connect to the RabbitMQ. Before RabbitMQ had finished starting, the container would crash. Instead of just starting them manually, I engineered as asynchronous retry loop inside the Python code. Now the service is smart enough to detect the refused connection, wait 5 seconds and try again until the message broker is ready. It makes the whole system fully resilient. I also had to strictly control the API responses. By default, FastAPI throws a 422 status code if a user sends invalid data. But my system requirements specifically called for a standard 400 BAT request. So I wrote a custom global exception handler to override FastAPI's default behavior, ensuring strict protocol compliance while keeping the helpful error message. By default, the fast API um, will ja- fast API by default the fast API will throws a invalid data for the throws a 422 error code for invalid or record invalid data. But I wrote custom global exception handler to override fast API's default behavior, ensuring strict protocol compliance while keeping the helpful error messages. To wrap it all, the entire system is fully tested using PyTest directly inside the Docker volumes like this. Okay, this using the PyTest, the entire system is fully tested and sensitive credentials are all securely managed through environment variables. Let's test this producer producer service. All are passes and let's test the consumer service. Okay, consumer service. All are pass. This this is the all the project running behind, and it was great experience building a decoupled architecture from scratch. You can check out the full source code and setup instructions in my GitHub repository linked below. Thanks for watching.